How do file permissions apply to symlinks? Let's say you have this structure. File 3 is a link to another file 3 somewhere else on the system. Now let's say I, chmod 777, the directory and all contents inside it. Does my file 3 in /tmp receive those permissions? Also, let's say we have the same situation but reversed. If I apply the permissions on the file being linked to, how does that affect the link?
It depends on how you call chmod and the platform you are running on. For example, on a Linux system, man chmod says this. Chmod never changes the permissions of symbolic links. The chmod system call cannot change their permissions. This is not a problem since the permissions of symbolic links are never used. However, for each symbolic link listed on the command line, chmod changes the permissions of the pointer to file. In contrast, chmod ignores symbolic links encountered during recursive directory traversals. However, on a Mac, chmod can be used to modify the permissions of a symbolic link using options such as this, from man chmod. If the file is a symbolic link, change the mode of the link itself rather than the file that the link points to. For the sake of example, let's assume you are on a Linux machine for the rest of this answer. If in the first case you run chmod 777 directory to recursively change the permissions, the link target will not be affected, but if you do chmod 777 directory / it will. If you change the permissions on the link target directly, those permissions will carry through, since as Man Page and Baraboom say, the actual link permissions aren't used for anything. Test log for illustration.
Baraboom's and Peth's answers are both correct. Permission bits on the symbolic links themselves are irrelevant, except on macOS, see below, and changing permission on a symbolic link, by the chmod command line tool or by the chmod system call, will simply act as if it was performed against the target of the symbolic link. To quote this of /POSIX.1-2008 description of symlink system call. The values of the file mode bits for the created symbolic link are unspecified. All interfaces specified by POSIX.1-2008 shall behave as if the contents of symbolic links can always be read, except that the value of the file mode bits returned in the st_mode field of the stat structure is unspecified. Here, unspecified leaves room of interpretation for each implementation. Specifics. On Linux, tested using ext4fs, stat returns st_mode equals 0777, no matter what the UMIS was when the symlink was created. LSL, therefore always displays LRWXRWXRWX for symbolic links. On macOS, HFS, and FreeBSD, both UFS and ZFS, a symbolic link does have its own permission. The chmod h command noted above can change this link permission, which internally uses a non-POSIX switchout system call to achieve this, and the stat system call returns this value for st_mode. Symbolic links on Linux and FreeBSD can always be followed, as specified by POSIX. In particular, on FreeBSD, this means that the file mode of a symbolic link has no effect at all on access control. On the other hand, macOS slightly breaks POSIX. Although a symbolic link can be followed regardless its read permission, read link fails with exes, permission denied, if the user does not have read permission. Note that the target portion is missing in the output from the second LSL command, and that cat symlink still succeeded and printed the contents of the target file even though the user did not have read permission on symlink. Next apparently offers a special mount option named symperm which, if set, causes symbolic link read/execute permissions to control read link and link traversal.
The following answer is about permissions implied ownership rather than read/write/exec permission bits. While the permission bits on a symbolic link may not matter, the ownership is important in the case of a sticky bit directory where everyone can create files such as o/tmp. Alice can create a symlink in /tmp, edit it and remove it. But user Bob cannot replace or remove Alice's link, tested on Linux. If Bob could do this, Bob could perpetrate an attack against Alice's resolution of the /tmp/mylink path that Alice trusts to be as created. Normally, removing an object depends on having directory permissions. This applies to symlinks. Bob certainly can remove a symlink owned by Alice in a directory that is writable to Bob, which doesn't have the sticky bit.